Hello, hello. Welcome, everybody. Welcome back to the latest Lilypad AMA. Just here. Oh, hey, Logan. Welcome. Welcome, welcome. How goes it?
Goes well. How are you?
All good. All good. I was very excited for this one. We got a lot of exciting developments going on the network and some cool news in the industry. But yeah, how are you doing? How's your week? We're midweek at this point.
You know, this week has been great. A lot of things moving as usual, which is always good. Um, but yeah, very excited to get into today's, updates, today's news, what's going on with the news, etc.
Oh
Thanks
yeah.
for asking, though. Thanks for asking.
Oh yeah, of course. Of course. Cool. All right. Well, I think my slides are now showing up for everybody, so that's awesome. Let's get into it. Thank you so much, everyone, for joining us on the latest Lilypad AMA. As always, we are here to answer your questions, so please don't feel shy to throw questions here in the chat. We are watching and will answer as they come. Hello, Roderick. Welcome. Super excited to have you. First as a Lilypad open source contributor, then an ambassador, and now joining the Lilypad team. Super excited to have you on the team. We got to set up a call in chat. All right, so let's just jump into the Lilypad vision just real quick. For those who are not familiar, Lilypad is building an accessible, efficient, permissionless open compute network. So the Lilypad network aims to democratize access to GPU compute for compute-intensive jobs, mostly AI models and other arbitrary programs that require GPU. So we've built this global permissionless compute network. Think of it as a marketplace for GPUs with a job-based model. And so running a job on the Lilypad network, you're not renting a GPU for a certain amount of time. You are paying per compute job. And so that's sort of a serverless architecture, and it makes it really straightforward for building on our network as we make it easy to sort of feed Lilypad into your workflow and use the compute, basically outsource us to us as your backend. And our big picture goals is to enable internet scale data processing for AI and other types of arbitrary compute, while also unleashing idle processing power. GPUs, whether it's a GPU they use for gaming or there's mountains of GPUs sitting at these big enterprises. A lot of times they're not being used, and so we're really excited to prove out the model of turning these cost centers of these big hardware investments into profit centers where you can actually generate revenue from that hardware and put it to work. So the way that this works is we have on the left hand side we have compute clients who use all of our tooling like our CLI smart contracts. We have an API and SDK in the works, in addition to a SaaS layer, to make it easy to interact with the network and use the compute, and also interact with the the Lilypad modules that are run on the network. So as you can see, sort of the big overarching piece of this is the module marketplace, which encompasses sort of the decentralized compute marketplace network, and then all of the jobs that can be run on the Lilypad network. Essentially, a job is a Docker image that's been configured to run in a certain way on Lilypad. And so we're super excited about the module marketplace as it unlocks accessibility for running AI models. Pull a model from Hugging Face and use our system to run it really easily on a bunch of GPUs. That's something that we can do today, but we're super excited to build out the SaaS platform to be able to do that. And then anyway, on the right hand side we have the compute providers, the GPUs. In the middle, they're matched with our solver, our smart contracts, and we are currently sort of acting as a mediator to be able to make sure that the behavior on the network is as expected, and the GPUs are behaving as expected. In the future, we'll probably have some kind of decentralized mediators. So the big call to action is always join the network with a GPU. Our incentivized testnet is live. You can earn Lilybit rewards, as you can see here on the right side. There's a leaderboard that you can check out at info.lilypad.tech. I have it on the next slide. But this is a one-stop shop to understand, okay, is my research provider online? And then, how many Lilybit rewards have I earned? So we kind of make it a fun, gamified system. But yeah, anyway, the incentive net is deployed on Arbitrum. We do aim to be multi-chain in the future. That's just where we've started. And yeah, get on board. So there's a ton of resources that we have. As I mentioned, the leaderboard, the blog there in the middle of the page, the Lilybit rewards have landed, is the one-stop shop for all the information about the Lilybits program. So go check that out. And of course, jump in our Discord. That's super awesome. We have an incredible community, super technical community. I think we have a lot of fun in there. We also get a lot of stuff figured out. So it's been incredibly helpful to have the community, contributing to what we're doing on a pretty much a daily basis. We do listen, and I think the community has noticed. We implement things that get suggested. So keep that up. And then at the bottom there, we've got our documentation, some other blogs, et cetera, et cetera. So the latest Lilypad release was 2.8.0. We've decided to name each release after, or to honor someone significant in the computing world. This time we've honored Edgar Dijkstra. I'm probably pronouncing that terribly wrong, but an absolute. Sorry,
Dijkstra.
Nice. Okay, I'm glad you're here to correct me on that one. So yeah, the absolute legend. And anyway, great quote. Simplicity is prerequisite for reliability. So that's a great quote. But anyway, with 2.8.0, we focused on a couple things. So you need a minimum balance of 0.0006 Arbitrum ETH to have your resource offer noticed by the Lilypad solver. We had noticed that number was a lot higher. And so that was one of the reasons that we were noticing jobs failing or resource providers not being noticed by the solver, actually. Because of the limit was too high, and so we've lowered it, and we do ask that RPs maintain that level in order to be noticed by the solver, so that you can get Lilypad jobs running on your machine. Another big sort of update is we're now having RPs run a local IPFS node. So before, we had an embedded IPFS node running in Bacalhau, which is one of the programs that resource providers run in order to be on the Lilypad network, and that was just not performant. It was causing problems, and we decided to just sort of separate ourselves out away from that. Also, the later versions of Bacalhau, we're on 1.3.2. The current version 1.5.0, and I believe the version before that had actually removed the embedded IPFS as part of the Bacalhau spec, and so we wanted to sort of prepare for that coming up by having RPs run a local IPFS node. And actually, this improves the reliability and speed of running jobs on the network. So, when a job runs, the output of that job is saved on an IPFS node, depending on how the RP is configured. It's either embedded on Bacalhau, or in this case, a local node that we're now having RP set up. And that needs to be delivered to the end user, right? And so if that output can't be, if that IPFS node is not accessible for some reason by the RP, or if it's not able to retrieve the data and provide it to end users fast enough, which we've seen a lot of, then it causes a lot of problems with job reliability. So anyway, we're super excited about that, and thank you to all of our RPs who have updated. Please update. You really are supporting the network by doing so. And at the end of the day, we are going to be moving towards giving rewards based on jobs that are being run. Of course, on Lilypad mainnet, the main source of revenue for RPs will be jobs that are run, and so. You want to do everything possible to make sure that you can run a job. And so all this stuff is very relevant to that. Anyway, so just wanted to mention that. Super cool. We have got a lot of awesome stuff going on in the community. So I just decided to highlight a couple of them. Over the weekend, there was a quantum community hackathon during LA Tech Week out in LA with our head of research, Stanley, who's an absolute legend. In collaboration with Dell Technologies and YouThink Academy. So the Lilypad team has been building a great relationship with Dell Technologies, and we've already partnered on a bunch of stuff, and a lot more announcements will be coming out soon. But this was an awesome opportunity to work with Dell and Lilypad in a hackathon type setting, and I think everyone really saw the value of not only being able to access idle compute, but then also some of the tooling we have in order to interact with it. So, this whole hackathon was about, basically running quantum simulation frameworks like NVIDIA's cuQuantum. Obviously, I'm not an expert in this, and so this is about where my knowledge stops. But I know this was a super successful hackathon. I saw there were a bunch of projects that came out of it, and we're really showcasing the value that Lilypad can bring to even emerging fields like quantum computing. And super excited to work on that with Dell. Another really awesome development is we're doing a lot of work with the BioML community. So obviously, you aggregate all this GPU compute, Now you want to make sure that people are using it, right? You want to make sure that the resource providers are earning money for that compute. And so we have like an incredible pipeline of demand for Lilypad compute. One of the big ones is for bio-ML researchers. There's a funny saying in Stanford, they have more PhDs than they do GPUs. So, I think they have like, I don't know, 50 GPUs or something like that. 50 GPUs and like hundreds of PhDs. And so for bio-ML research within universities, labs, and even getting into like pharma companies, we can provide computing resources to help make that happen. And then the tooling to be able to use those serverless, tasks, those Lilypad modules in a workflow to do something like multi-step enzyme design. So again, I am not the expert here on this, but this was from Amelie Schreiber. She's an absolutely brilliant bio-ML researcher, sort of leading the field. And so we've been doing a lot of work with her on how can we get her more compute and what does her workflow look like and how can we support that? And so, yeah, we're really excited, especially as the module marketplace grows, to have developers like this, building models and then making them accessible on Lilypad and then providing compute to run that. Super exciting. But as you can see here on the right, we got some protein folding going on with RF diffusion, which RF diffusion is essentially a text to molecule LLM. And so, we're folding proteins, we're creating new frameworks, we're essentially trying to help reduce the time to new drug discovery. And so, the fact that we can be involved at all in, accelerating medical research is just so cool. And our team is so proud to support that. So, I meant to put the link here. Oh, shoot. Anyway, if you just look up a new era in multi-step enzyme design, there's this brilliant Hugging Face blog from Amelie. Talks a little bit about using Lilypad also. So do go check that out. And I actually have this really cool video real quick from Amelie. This is some of the work Amelie did. And so, we've got a lot going on here. But essentially, this is the kind of outputs we're looking for from these processes of folding proteins. And so anyway, that's just so cool. I figured everyone would want to check that out. But anyway.
Play it again.
Oh, yeah.
Yeah, essentially, like each one of these proteins is a puzzle piece. And so you need to fit each protein in like the correct spot, according, because they're all puzzle pieces. They only fit certain ways. And so that's what I guess this is doing. I mean, I'm
more or less, yeah. I mean, my understanding is that like there's certain things in certain parts of the protein structures that like need to be evaluated for a rare disease research study that are known. And then there's certain parts of that structure that are unknown or maybe not like consistent. And so these LLMs basically help to like model that out and I think explore like different like alternative structures and almost like simulating out like what these structures would look like. It's probably as far as I should go on that. But yeah, it's very cool work. And anyway, we're super proud to help support that. The question is now, how do I get out of this? You guys can just keep watching this for the rest of the stream if you want. That would also. I'm going to stop sharing here. Oh, yeah, there we go. Okay, technical glitch here. Note to self, maybe don't put another video. No, I'm joking. That was awesome. Okay, so the next awesome thing that's going on is we launched our ambassador rewards program. We had been saying this for a long time. We were going to do this, and so now we actually did it. We have a group of fantastic community contributors called the Lilypad ambassadors, and these are individuals who show just a lot of commitment to the community, helping set up research providers, being in Discord, answering questions for the community, sometimes contributing, tooling for RPs. I know Kabbalah Rasa, the contributor, right here at the top of the list, built a bunch of tooling for, monitoring an RP with like a Telegram bot. I believe he had like an auto update program. Rudderbrek, also the number 2 on the list there, also had quite a bit of contributions around tooling. So yeah, we just wanted to say thank you to our ambassadors who are awesome. And these are the current 5 right now, but we're trying to grow the group. Logan, I know you interact with the ambassadors a lot. It's awesome to have like such a committed group, right?
Really, really just goes to show how the internet, creates just knowledge I guess, bandwidth paths for knowledge to spread. I'm just incredibly happy and amazed to see how amazing the community is. They're so intelligent. They are so smart. They can notice something before I think we notice. And yeah, just thank you guys all. Thank everyone so much for all of your support on the technical side. But especially the ambassadors, especially some of the individuals in our Discord responding to some technical questions. Like, you guys are amazing, and yeah, you guys are really what make community great, in my opinion. So thank you all so much. If there's any questions, if anybody has any technical questions, though, feel free to reach out. We'll get you an answer, and if we don't, maybe someone from the community might.
Oh yeah, absolutely. And then there's a lot of perks to being an ambassador. Of course, now we're giving out rewards once a month, so that's really cool. But also, you see on the right there, we've got an ambassador channel where you can kind of, if you're one of the ambassadors, you can kind of have a direct line to the team, which has become incredibly useful for testing things, triaging questions, and getting some stuff done. And as you can see, there's some awesome charts that have been created here from our ambassador lead, Caballerosa, who has done some awesome like tracking of transactions versus like expected transactions versus transactions that are being seen. So anyway, very cool stuff. I figured I skipped a slide. Yeah. Okay. So Hacktoberfest is ongoing. Obviously, end of October is coming up, so you got to get your contributions in now. If you go to the Lilypad GitHub repo, the link is down there in the bottom corner. You'll see a bunch, and you go to issues. You'll see a bunch of issues that we've tagged as community issues, and these are open source issues that we want. I mean, we want the community to contribute in general to our repos. There's a bunch of issues that have been specifically marked for community that, in the effort of like streamlining how we what issues people could pick up. They're also now tagged as Hacktoberfest, and so if you pick those issues up and get them done, they get sort of counted in part of this Hacktoberfest open source celebration that's going on. So go to hacktoberfest.com if you want to read more about it. But yeah, we're super excited to be part of that, and it's been a fun month. It's already been a few weeks of it going, and the contributions have been awesome. So the big call to action here is to get involved, whether as a resource provider, whether you're building a Lilypad module, you're trying to get like some program or AI model to run a Lilypad, build a front end. There's a lot of different places to contribute. Help us make educational content. Come contribute in the Discord, answering questions. There's a million things to do. So check out our Discord, check out our website. We put blogs out all the time, project reports every 2 weeks, and tons of other content about what's going on. And yeah, check out our docs. That's really the one-stop shop for information about what's going on and sort of like how to use the network. And so yeah. With that, I think we should stop. I should stop just talking to myself here. No, I'm joking. And figure out, if anyone has any other questions. But if not, Logan and I, as usual, would like to jump into what's going on at Lilypad, what's going on in the industry. But yeah, thank you all so much, as usual, for coming to hang out with us. Yeah, Logan. So we got a lot going on the engineering team. I don't know where you want to start. I don't even want to. I want you to figure out where we should start. We're pushing updates to IncentiveNet. A lot of what we've learned is being fed into our mainnet, planning and architect. That's all being architected in conjunction with the white paper and tokenomics. So all of that's happening at once, and all the information from all those places are kind of being fed together to weave this tapestry. So yeah, I know. I mean, maybe one thing we can jump into, like, I know we're looking at multiple architectures for GPUs. We want to be able to, if we want to democratize access to GPU compute, we can't just be, supporting NVIDIA GPUs, right? So it definitely makes sense. I actually believe that the more types of architectures that we support, we can actually lower the cost of compute, at least on our platform, simply because of more supply, right? It's market economics, right? More supply equals lower cost, assuming the demand stays consistent, or if it goes up, the prices could change. But anyway, I know you're working on that. What's going on that front right now?
Right. So apart from pricing and modeling, the costs of all of this, keeping that, taking away that variable, just simplifying it a little bit. I think it's the more I learn about it, the more information I see. It is good to just have two separate runtimes just for technical workings. Just NVIDIA CUDA works differently than say OpenCL or ROCm or other types of I guess driver frameworks, etc. Like CUDA is a very extensive lists of tooling, and so it's really hard to see where the line ends in terms of okay, like is this just GPU or is this software stuff too? But yeah, very very excited to take a big deep dive, figure out what we need to change in Lilypad to make us runtime agnostic, be able to support multiple runtimes. We are starting with possibly ROCm, or I'm also looking at OpenCL is another option, but it seems as if ROCm is going to be the taker here. But getting if anybody asks me and they're like, okay, I want to buy a GPU so I can run jobs, I won't I probably won't tell them, I won't recommend getting an AMD GPU quite yet. I feel like there's still quite a lot of work in terms of development and making it easier to just turn it straight on. But I have found a lot of I've just it's not that intense to run models on AMD, which I was very surprised about. I've been doing a lot of reading and a lot of people say very negative things, and I was able to get SD Next set up like super quickly. I mean, you saw it's not too difficult. It is tedious. It is. I will recommend people get an NVIDIA GPU for now, especially if they don't want to spend a lot of time working with their driver installs and but
yeah, that's one thing I know you were telling me a lot about is kind of like the problems around running AI models on AMD cards. Like just to begin with, the ROCm drivers are, my understanding is they're not very stable. Or is that the right way to think about it?
Yeah, that's a good way to put it. It's just there's you have to account for those stability problems. Like I have never seen feel free if someone put it in the chat, please, if you have seen a CUDA driver, the CUDA driver fail. So like, I've never seen the CUDA driver fail ever. But I have seen the ROCm driver fail a bunch of times, and it's not very graceful. I mean, it's hard to even turn the computer back on, which is really weird to me. I've never had that. But so essentially what PlayStation, what Sony does, what Tesla does when they're working with their ROCm or AMD GPUs is they have to account for those runtime errors, for those runtime inconsistencies. So I think they just you have to write better code to account for it, and that's what we can do at Lilypad, in my opinion. We can account for some of those runtime errors. A lot of this currently is left up to the resource provider themselves. So figuring out what we need to do to make it stable, make it work is my
Yeah. And like the more we learn about this, the more it feels like a major opportunity here to like knowing about the problems with, ROCm drivers and running, especially like large processes like AI models on those cards. It feels like Lilypad can really be, part of the software solution to that. Like you were saying, basically like account for that in our system, like PlayStation or Tesla.
Exactly. It's we individuals don't want to have to make their own code to make this stuff run, and so if we can be a layer to provide that stability, a developer won't have to worry about configuring the ROCm drivers themselves if they just want to run a model that the guy who owns the individual who owns guy or girl, individual who owns the ROCm GPU, the AMD GPU, they can be the one who worries about making sure the drivers are configured, and we can be the one to make sure that the runtime is working correctly. But it's been a huge learning phase, figuring out the differences between the two big companies, AMD and NVIDIA. I'm a huge supporter of both, of all of them. Bring on the GPUs. I love it. Very excited for Apple's Metal X, pushing, the boundaries of making GPUs more and more efficient. Thank you, Apple. But yeah, it's very exciting. It's very exciting.
Yeah. Yeah, I said we were on a X Space yesterday, and I was mentioning this, and I was like, it occurred to me, I was like, this started as just an investigation of like, let's see what's possible, and now it's actually turning into like, here's the roadmap, or it's like turning into a sprint on the roadmap, which I think that's pretty cool. Like when you have an investigation that turns into to an actionable plan with something like this, that's incredibly exciting. And yeah, I mean, like, we're seeing in the industry that there's a lot of people trying to run AI models on AMD cards for different reasons, having different successes and failures. So yeah, the more that we can help simplify that process and basically abstract away a lot of the issues and complexity, it definitely feels like we'll open up quite a bit of market share for everybody in terms of getting access to compute. There's a lot of people with AMD cards that would love to put them to work, especially big enterprises. Like, the more we talk to big enterprises, they're like, oh yeah, like we would love to get our AMD cards to work.
Yeah,
to work.
Definitely. The VRAM tax that NVIDIA charges is just absurd. It's insane how expensive some of these cards are getting. Even an old 3090, which is an insanely beautiful card. I mean, they're still at $800, $900 for like a standard cooler, and like the fancier, bigger coolers are going to be like still $1,000 for a card that is multiple years old at this point. And that VRAM tax is really heavy. The AMD's cards, you can get quite a lot of VRAM for nothing. I mean, for very little. 16 gigs of VRAM for $550, $600. Very, very affordable, very performant. Not the same though. the
CUDA software, right, is pretty entrenched. It's pretty established.
Exactly. It's all encompassing. There's so much tooling to help you. But AMD, that being said, AMD, like, figuring out what the NVIDIA card is doing specifically, like there's like NVIDIA Insight, there's a lot of like tools you can use to like observe and monitor and log what's happening on your NVIDIA GPU, so you can see like what's happening when you're running a model. But I've noticed that AMD has a ton of tooling around it as well, and so even more tooling, and it's the stack to set it up is, I think, in my opinion, a little bit easier on AMD. NVIDIA wants you to create a user account, and they want you to like sign in, and they want you to have the serial number for the GPU that you bought, and AMD is like, yeah, go download our GPU profiler on GitHub and run it,
and go figure it out.
Well, yeah, exactly. That's true. They're like,
oh, I didn't mean that as a negative. It's just sort of a different philosophy, right? It's like, weren't you also telling me that sort of that AMD drivers are a lot more open source, and that's kind of their philosophy is kind of just leave it to the open source community, or is that not necessarily the right way to think of it?
Yeah, they've just started open sourcing a lot of their drivers and stuff, and so has NVIDIA, which is great, which is really great. But we still have a long ways to go, in my opinion. Yeah, it's a lot of, even I will look at these companies in such a like high pedestal. I really like, I'm like, oh, NVIDIA, they're the gods. But at the same time, we need to recognize that they can also be be very limiting in terms of innovation and stuff in a lot of ways. Like the more you hide behind licenses and closed source, the less the community will be able to accomplish. And so that's why I feel like the past 2 years have been such an incredible amount, like period of time, to see AMD and NVIDIA embrace the open source mentality, to be able to spread these tools to everyone, is why it's growing so quickly. And so if they didn't do that, we wouldn't have the growth. And so it's just great. It's just so good. Like when I was at university, I like seeing, like trying to get my MacBook to run a NVIDIA GPU. It wasn't like an external GPU, so like plugging a external GPU to a MacBook. You could do it with an AMD card, and I had a lot of, like, it was awesome. One of my buddies from school, I was like, "Can I borrow your AMD card so I can do this?" Sure. It was like a RX 580, and when I would try to use like an NVIDIA GPU, the drivers, NVIDIA and Apple were like at the time not getting along, and NVIDIA didn't open source the drivers to Apple, and so it didn't work. And so it's like nowadays, I don't know if that's still a problem. Good question. I don't know if Apple and NVIDIA, like, I don't know if you would even want to hook an NVIDIA GPU up to an Apple M1 device at all, but I don't know.
Yeah. Yeah. So along these lines, like obviously the whole point of this is to run modules, right? Is to actually to run compute jobs on these GPUs. So how are you seeing? I know that right now you're sort of testing all this, but how are you running? Which models are you running again on that AMD card? I know you're testing some different models. I'm curious, how are you seeing like the performance? Are you seeing any difference than to like standard like NVIDIA card, like a 3080 or something like that?
Yeah,
I know you're
definitely
trying to figure out models running on those cards well.
Yeah, definitely. So like I've gotten SD Next to run on this AMD 7800 XT, I think is what it is. So like SD Next is just an insane, beautiful piece of software that you can download on GitHub. Just insane. It holds a ton of basically you can choose from a list of a lot of models. It'll download that model and you can run it. And the beauty about SD Next is you can run it on tons of different runtimes. You can run it on an NVIDIA card. You could run it on an AMD card, even an Intel maybe. I'm not quite sure. And it works so great. What I have seen is like when I'm running Docker modules that are running inference on my NVIDIA card, if I like give it a model that's just way too big, my NVIDIA, what is it? I've got all these graphics cards in my head. I can't keep track of them. I've got this NVIDIA RTX. What is it?
Is it 4060?
4070 Ti. I've got a 4070 Ti. So I'll run a model on it, and if the model is just too large and I'm going over the 12 gigs of VRAM that I have, it'll just like the Docker image will just like fail or something. Like it'll give me an output. It'll say like, hey, I tried to allocate this much memory, only this much is available, sorry, I'm out. and it failed. And so great, so I'm like, oh, I'm running a model that's, I can't count. Okay, go fix that. Whereas on the AMD, when I tried to run a model that is over the weight because I'm not counting correctly, it just turns. It's like, all right, computer's off. It just will.
Oh, wow.
The whole computer will just turn off, and so yeah, that's not good. And so
That's not what we want.
Right. If like an RP is running and their machine is like doing good, it's up, and somebody's like, okay, let's run a model on this, and then it just is like the model is way too large for the GPU. Like our solver will really need to be able to match that job based on the job spec. So yeah, like make sure that allocation is correct. But other than that, the when I am counting correctly and I can get the the numbers right, and I'm running models that actually fit onto the VRAM, it is super incredibly performant. Just as NVIDIA, I would say using SD Next, they look very, very similar. Like the outputs can take maybe a little longer on AMD just by nature, just because there's probably not not as much optimization in my opinion. But yeah, no, it's incredible, super awesome. Very excited to get it working.
Yeah. So is SD Next larger or smaller than like your standard Stable Diffusion, like 1.0?
So sorry, SD Next is kind of like Comfy UI, in that you like run Comfy UI and then you run a model within Comfy UI. It's just kind of like a orchestrator type of thing, and so that's what SD Next is. Sorry.
Oh no, that's my bad. Yeah. So was it SDXL Turbo that you were running using SD Next, or what was the model? I don't remember.
I was running Juggernaut. So I was running Stable Diffusion Juggernaut XL. I was running a super lightweight model. I was trying to run Flux. That didn't really work too well. But
Flux. Yeah. Oh yeah, the new kid on the block. I don't know how new it is actually, but exciting alternative to SDXL. What's your take on Flux? I know you were playing around with it.
Yeah,
I need to try it out.
It's pretty awesome. I know on Twitter, I finally bit the bullet and I don't know if that's a good form of speech. Bit the bullet. I don't know where that saying came from, but I essentially bought the year-long membership on Twitter or X, whatever you would like to call it, and I've been messing with Grok, and Grok's text to image will use Flux. And so I was, talking with one of my colleagues, Arson, and he was like, have you worked with Flux? It's the new SDXL. It's the new, like everybody went to Stable Diffusion. Now everybody's going to Flux. And so, running it locally and then running it using X's, implementation on Twitter. It's been awesome. I love Flux. It's crazy how realistic it is. And yeah, like I'm full steam on Flux.
Nice. Okay, so
what else do we got? We need other recommendations other than just what we have. If anybody has any awesome models, we always got to stay on the cutting edge.
Yeah. I mean, our team has been the first ones to build Lilypad modules that you can run on our network with our CLI. But the intention is that it's a community-driven thing. So yeah, if the community has ideas for models that you want to run on Lilypad, reach out to us. But go check out our docs. I mean, the docs are pretty straightforward for how to like configure that Docker image. I mean, I know there's a lot of nuances that you might need some help with, so you can hit us up in the Discord, no problem. But come up with models that are useful and then add them. That's like a huge call to action. We're actually going to be incentivizing that. I think the intention was to incentivize that by now, but I think we're pushing that a little bit as part of the second phase of our incentive net. So the first phase has been to incentivize resource providers, right? Anyone running a GPU, you earn Lilybit rewards. Those rewards will be redeemable for Lilypad tokens on mainnet launch. We're also giving Lilybits to the community. As you guys saw, we're giving Lilybits to ambassadors, we're giving Lilybits to open source contributors. The next big stage of incentivization will be for module creators and integrations and front ends being built. So yeah, if you got ideas, even to the shout out to the Lilypad ambassadors too. I know you guys have great ideas. Help us, we'll build stuff and then help us figure out what needs to be built and how we can better support that whole growing side of things. Logan, I feel like you and Arson are kind of like the internal knowledge base of building modules. I think maybe not, but I think you guys are kind of leading that charge. It feels like you guys have been doing a lot of work to make modules run better our network. Is that the case, or like what's kind of like the status of how we think about building modules these days?
So yeah, there's been a lot of talks in the team on how we can accomplish said goal of building modules, being able to run. Essentially, like with Lilypad, you have a graphics card that is broadcasting itself to the network. You have a RTX 4090 that's saying, "Hey, I can run a job," and all that means is whenever somebody on a CLI says Lilypad run, it will ask the network to pull down a GitHub repository, whatever that GitHub repository is, and to run the Docker image within it, or to run the set of instructions in it, basically. And so, like there's been a lot of pushes to sometimes abstract a lot of that away from the user. Something that I've been doing, as well as some people within product, is to retain the idea of what is going on here. Like, we have a very simple method of doing this pipeline, getting this process to happen. And the more we abstract away things, the harder it is for our users to understand what's really going on when it is very, very simple. And so for the most part, at the beginning here, we are keeping everything as simple as possible to make it as understandable as possible. But there is also a lot of push in the later frame of time to abstract a lot of this away to make it like super, super easy, while also helping people and individuals understand how these things work and how we can enable them and how we can take advantage of them. This has to work. This has to agree with the OSI layers in my opinion. And so having people understand that as well is super important. So
yeah, when you abstract away everything, it's true, you sort of leave less information for the user or the developer to kind of like understand what's actually happening under the hood, which in some cases is like an issue. Like, we want people to understand how these things work, and so I think that's like kind of where we are right now. It's like you're kind of getting into the weeds of it, but I'm also excited like for the module marketplace, so sort of like our SaaS platform that we are building out and we'll continue to build out over these next months. Making it easy for like non-technical users, whether it's like some machine learning researcher who's just trying to like get a model to run, and they just need the outputs from that model. Like making it really easy to like potentially even like with like 1 or 2 clicks to get something from Hugging Face all the way over to be able to run on Lilypad. There's kind of like a duality there of like we want both scenarios, and I think we'll probably make it like that, right? Where you can run a module, just use Docker, use the CLI, good to go. Or if you need a much more tailored solution, like we'll have that available also.
Right. Yeah, as a startup, you and I know very well, as being startup operators, we want quick and easy solutions to do enormous, amazing things. And so that's what's cool, is there's a solution for everyone. But if there is a model that you do like, and it's not found, on the Lilypad, being able to show like, okay, this is how you create your Docker image. This is how you install everything within the Docker image and build it, and then publish it to GitHub or Docker Hub, and then make the instructions for Lilypad to run that Docker image. It's not as absurd and crazy and as difficult as you would think. And so having a piece for everyone, very awesome, important, needed, required.
Totally, yeah. As much opportunity for different like skill sets and different needs, because a lot of these things are so nuanced. Like they're so, like for example, the BioML workflows, like their intention is to not use just one model, but use like 4 or 5 and string them together in a workflow, right? And so that's a very specific, different thing. And so they need tooling to do that, and we're super excited to be supporting that. We actually have a internal product that is being tested that sort of like this module marketplace SaaS product we're talking about here. And so to be able to like string together a workflow of like 5 different models where the output from model 1 is then the input from model 2, and so on and so on, to then result with, a protein, an enzyme, or even like some new drug that can be produced to solve a problem. Like that's incredibly exciting.
Right. It's especially like within the team, I really enjoy the contact and the I guess working together with the bio ML and the research team. It is the part that pushes the boundaries of Lilypad to extreme levels. Like a lot of the situations in which we're running Lilypad right now are running within like single card configurations, within a logical amount, in my opinion, of VRAM, say like 20 gigs or 22 gigs, 24 gigs of VRAM. Whereas these, when I talk and work with the research team, I am just like, it's a whole different type of game. It's a whole different type of ballpark. They are not working in 22 gigs of VRAM. They are working with 220 gigs of VRAM. And so just orchestrating that on I tried to talk about this sometimes, like trying to orchestrate any type of ML sequencing, any type of inference can be difficult, just in terms of a technical endeavor. Being able to move, hundreds of gigabytes of data in split seconds is only something we've been able to accomplish with modern hardware in the past 4 years, maybe like 6 or so if you're using server gear. And so to be pushing 220, 300 gigs of VRAM to run some inference is, in my opinion, really difficult. And it's awesome to get comfortable with that and to be tested and to be like really pushed, and then to be able to start trickling that down to the actual network instead of being a test network situation.
Yeah, no, I mean, that's wild, right? And like we're lucky enough to have some A100s on the network. I know we have some GH200s coming online too. So we've got, VRAM available to do some of this kind of stuff. But as you said, it's very complicated to actually orchestrate such a big process, especially when we're like stringing together multiple workflows, or I guess one big workflow of like multiple modules.
Right.
So
Big thanks to all of our hardware providers who are offering their resources to us, apart from just being testnet members of the testnet. They are also we have a lot of members who provide us server resources just as an SSH key. And so big thanks to all of those. I won't point out names, but you all know who you are if you're listening. Thank you so much for giving us access to your incredibly expensive pieces of hardware.
Yep. Well, I think that pretty much covers it. We got a lot of exciting stuff going on the network. We got a lot of moving pieces here, as you can all see. The team is like just guns blazing, headed towards mainnet launch. Simplifying variables in terms of like what we're trying to get accomplished by then. Feeding in everything we're learning from the incentive net and from resource providers and talking to partners and people's experiences running models. Like all of that's being fed in down the pipeline for our engineering team, our product team, even our DevRel team. Like how do we do this in the right way? So a lot of exciting stuff going on, and it's been sort of a pleasure to watch the community grow and to have the community support us. So thank you all seriously for everything you guys are doing, and don't stop. We have a lot of incentivization already, and there's more incentivization coming, and so we notice the work that gets done. And I think especially you can ask ambassadors or open source contributors, work does not go unnoticed. So we really internally are very focused on our community, very focused on our customers, and so that's something that we push internally quite a bit and is a huge priority. So thank you. But with that, we will probably end it here unless we have any other questions. But do join us on the next AMA. We have another one with developer Steve and Tao Sheng next week at 12 p.m. or 9 p.m. Eastern Standard Time in the U.S. That's for a much more convenient time if you're sort of in Asia or in the Middle East or sort of on the other side of the planet from where we are. And then come back and join Logan and I in 2 weeks from now, same time, 11 a.m. Central Time, 12 p.m. Eastern Time, and we will bring the latest and greatest from Lilypad. We got to get our head of research on here, Logan Stanley. He's such an awesome character and has so much to say especially about BioML, but just in general about sort of the growth of the machine learning community. So maybe keep an eye out for that. We'll promote it, but we're gonna try to get Stan on here on the next one.
Absolutely. Thank you so much for hosting us, Alex.
Oh yeah. Oh man, it's fun. I mean, this doesn't even take that much effort, right? I mean, it's not hard to talk about such amazing stuff, right? It's actually the hard part is figuring out like what to put in these slides because there's so much going on. It's like, what should we focus on? We don't want to talk about like 100 different things.
Right.
Anyway, sweet. All right. Well, great to see everybody. Thanks for coming, and we will see you on the next one.
Peace.